Client-server architecture. Sometimes an application structure takes on a client-server nature. The server application provides services, such as access to a database, serving network time, authentication and access to shared resources, or serving out chat conversations. Client applications are then created which make use of these services. To initiate a point-to-point client-server connection, the transmission control protocol is used. TCP is a reliable protocol. In other words, it guarantees the delivery of the data it transmits in the form of packets. If packets are lost or damaged, TCP will resend the data until it verifies that packets have been successfully transmitted. TCP is needed for applications that must reliably send messages back and forth or initiate file transfers to ensure that a perfect copy of the data arrives at the other side, uncorrupted. This brings us to our next point, TCP/IP sockets. When establishing connectivity, the client and the server each bind a socket to their end of the connection. Once a connection has been established, the client and server both read from and write to the socket when communicating. If this is new to you, you may still be asking yourself, what is a socket? A socket is a combination of both an IP address and a port number. Each socket used in client-server communication is an endpoint of the two-way communication link used to send packets between applications. Multiple TCP connections can be initiated between each client and a server, and each connection is unique by its combination of ports and endpoints. The server runs on a specific host where it creates and continuously listens to a server socket that is bound to a specified port number and waits for clients to make connection requests. The client must know the correct port and the IP address or host name of the server to initiate a connection request and identify itself. When the server accepts the client's connection request, the client also creates a socket, and communication between client and server takes place as both read from and write to their sockets. Java uses the socket and server socket classes from the JavaNet package to implement client-server communication. In the server application, once a server socket has been instantiated with the designated port, a new socket is created to accept the server socket's connection request by calling the accept method on the server socket object. Then, InputStreamReader, BufferedReader, and PrintStream class objects are instantiated. The BufferedReader object's readLine method is used to retrieve input from the client, and the PrintStream object's PrintLine method is used to send output to the client. In the client application, a new socket is created if the server's server socket accepts the connection request. The connection is requested by instantiating a socket class object and passing in the server's IP address or host name and the selected port as arguments. Then, InputStreamReader, BufferedReader, and PrintStream class objects are instantiated. The BufferedReader object's readLine method is used to retrieve input from the server, and the PrintStream object's PrintLine method is used to send output to the server. To summarize, let's look at the process for coding these client-server applications. First, create a socket or server socket object and open it over a specified port and IP address or host name, thus creating a socket. Second, instantiate InputStreamReader, BufferedReader, and PrintStream objects to stream data to and from each socket. Third, read from and write to the stream between the sockets using their agreed-upon protocol and port. Fourth, close the input and output streams. And fifth, close the socket or server socket objects. Here in this example, we have a very simple server and a simple client. So first, let's take a look at the server. The very first thing that you'll notice is what we need to import, these packages. I/O for basic input and output processes, for all of our streaming objects like BufferedReader and InputStreamReader. And then we also have to import java.net to give us our sockets, our network tools. So with our two imports, we create a simple class in NetBeans. And because this is not extending JApplet or applet, there's no init method or it's not even a JFrame. Just a very simple console application. So it needs a static main method so that we can basically build an instance of it and start everything running. And so that's all we're doing here in our static main method. And pretty much everything that we do with streaming that involves sockets is going to have to be inside of try and catch blocks. So you'll have to get used to that. So it's either I need to add the curly braces and try and catch around everything, or I'm going to have to code my functions to throw an exception. And in this case, I'm just throwing a plain old vanilla generic exception, sort of the granddaddy of all exceptions. But notice my main method, the name of my class is sock1 server, and so I'm building a sock1 server, and the instance is server with the new keyword, and then I'm simply going to run. I'm going to call run on it. All right, and then in the function run, here's what happens. We're going to build or instantiate a new server socket called srv sock. Okay, and it's going to open up on port 444. So 444 or 444. When we do this, I'm then going to turn around and build a new socket, whereas this was a server socket, this is just a plain old socket called sock. And what I'm going to do is I'm going to call the accept method right here on my server socket. And the return value that I get from that, sort of a pointer, is going to be assigned to point to this socket object here, sock. And once I do that, then I'm going to instantiate or build an input stream reader called IR, that's the instance name. And the argument is going to be the input stream. I'm going to call the function, in other words, get input stream on the socket here. And remember, this socket received the return value of the accept method from this socket, open on port 444. So can you kind of see how everything is connected, how everything is chained up? It's sort of this big chain of cause and effect here. Okay, once I do that, then I'm going to instantiate or build an instance of the buffered reader class. I'll just call it BR. And when I do that, I'm going to pass in my input stream reader, which I passed in my socket calling get input stream, which received the return value of accept. So again, just notice how everything is connected. Okay, I have a string here called message. And what I'm going to do is I'm going to read a line from the stream, the input stream here from my socket, and I'm going to go ahead and assign that or store that in that string there. And then when I do, I'm just going to turn around and kind of echo that system out print line message. All right, I'm going to show what I received from the data stream, all right, from my input stream. And in this case, if the message is not equal to null, if I actually got something, then I'm going to build an instance of the printStream class. My instance name is PS. Okay, and then as an argument, again, now I'm going to pass in, instead of calling getInputStream, I'm going to pass in my socket object again, but this time I'm going to call getOutputStream. So this was the input, this is the output stream from my socket object. And then once I do that, I'm going to go call the printLine method, and I'm simply going to say message received. And this will have the net effect of sending this out or bouncing it back to the client. So in other words, this line here is going to show me what I got from the client, and it'll be displayed in the console where the server is running. Whereas this line here will then be sent to the client. Okay, message received. It's confirmation being sent, so the person running the client on their computer would see this message, whereas the administrator running the server on their server would see this message. Hope I explained that in an unconfusing. Anyway, that's the server part of it, okay? So let's take a look at the client part of it. Client part of it, notice I'm importing the same two packages for the same reasons, IO and net. Name of the class is sock1 client. I'm doing the same thing with my static main method. I have to build an instance of the class to get it to run, to get it to start doing things. So my instance name is client. Use the new keyword, build it, and then I go call the run method. Again, everything has to be on try and catch with these sockets, or I have to throw the exception. So in this case, I'm throwing an exception from the run method. Here, I'm building a socket called sock. The instance name is sock, and this could be an IP address, this could be a host name, this could be a domain. In this case, it's localhost, the loopback 127.0.0.1 or localhost. Okay. So a combination of hostname or IP and a port, which is 444. And it has to match the server port, right? There's a server port 444. Here's the client port 444. They have to match exactly. They have to link up and hook up. Okay, once I've done that, then I'm going to build an instance of the printStream class. And I'm going to take my socket and I'm going to call the method getOutputStream. Okay, and this is what's going out from the client to the server. Once I do that, I'm going to call the method or function printLine on my instance of printStream. And when I do that, I'm going to send hello to server from client. So this will go out the data stream, from the client to the server. And the administrator on the server would then see that. He's running the server. Okay, when I do that, now I'm going to build an instance of InputStreamReader called IR. And this time I'm going to pass in my socket once again. But instead of OutputStream, where I was sending something to the server, I'm going to call the method getInputStream. So I'm going to be listening for something coming from the server, coming back from the server. Okay. When I do this, I'm going to build an instance of BufferedReader. I'll call it BR. And I'm going to pass in my instance of InputStreamReader, IR, as an argument or a parameter. And then I'm going to read a line, in this case from the input stream, right? Remember, we called getInputStream. And I'm going to assign it to this string. And then once I do that, I'm simply going to system out print line in the console and display what that string is, whatever it is that I receive from the server via the input stream. Okay, so if that explains things, we always have to run the server first. We have to launch the server first, and then once the server's running and listening, the server socket's been built, port has been established, it's ready to accept the connection. Then and only then can we then run the client, and then things would work properly. So in the spirit of what we just said, I'm going to go ahead and right click on the server and run that first. Okay, and notice firewall pops up. Yes, I'm going to choose to allow it access, even though it's my loopback or localhost. But alright, so it's just sitting there running. Okay, not doing anything, but it's listening, it's waiting. Now with the server running, now I'm going to start the client in the appropriate order. And notice the client says message received, and that came from the server. Let's go look at the server's output. And the server received hello to server from client, which is as it should be.